Today, we're going to figure out how to substitute in systems of linear equations. Now, first of all, what does it mean to substitute? It means to put one thing in place of another. Right. That's what we're going to be doing today mathematically. Okay, it's not hard. The concept is rooted in sense making. It makes sense because if I said that 7 equals 5 plus 2 and 5 equaled 4 plus 1, theoretically I could substitute in place of this 5 this side of this equation, because the expression 4 plus 1 is the exact same, equal to 5. So I could really use substitution to do this. Is this still a true statement? Absolutely. 7 equals 4 plus 1 plus 2. So I can substitute one expression in for a term as long as they're equivalent, as long as they're equal. Another example. Okay. What if I said 7 equals x plus 4? We know that x should be 3, but over here, what if I said x equals 5 minus 2? I can plug in, since I'm telling you these are a system, these go together, I can plug in this value for x in place of this x. So I can rewrite this as 7 equals, and sometimes we can use parentheses to help keep everything in order, plus 4. Now, so does 7 equal 3 plus 4? Of course it does. This again is an example of substitution. Now, let's look at it with an example of two linear equations. You can think about the fact that linear equations are graphed on a coordinate plane. And so if I give you a couple of equations and I say they're both part of the same coordinate plane, that means that if I have two lines, say I've got a line going like this, and a line going like this, any place along this brown line, if I pick out an x and a y value and I plugged it into the equation, it would match up with this line. Any place on this line, if I picked out an x and y value, same thing, it would match up with the pink line. So right here, where they intersect, that means, like you saw in the last video, that each equation has the same exact x and y coordinate pair that is a solution. Okay, so let's look at the equations. Now these equations don't really match up with that graph, so don't try to rationalize that. I'll erase the graph. But remember, we're talking about substitution. So what can I put in place of what here? Well, if y equals 3x plus 4 and y equals negative 2x plus 2, I can substitute this expression in place of this y, because y equals two different expressions, but they both equal y, so they equal each other. So I can rewrite this as 3x plus 4 equals negative 2x plus 2. Now what do? I need to solve for x. How do you solve for x? The same way you would solve for x with any given equation. Just because this came from two separate equations, it's now sort of one combined equation. So I like to have positive x's when I can, so I'm going to add 2x to both sides. So I get 5x plus 4 equals 2x's. Negative 2x's plus 2x's is 0. They cancel out, equals 2. So now I'm going to subtract 4 from both sides. 5x, 4 minus 4 is 0. 2 minus 4 is negative 2. And now finally, to solve for 1x, if 5x is equals negative 2, divide by 5, divide both sides by 5, keep it in balance. 5/5 is 1. So I'm left with 1x equals negative 2 fifths. That's a 2. So x equals negative 2 fifths. How can I solve for y? If this is my x value, I can plug in x into either equation to figure out the y. Let's do that for both. So the first equation, y equals 3. Remember, in place of x, I'm putting negative 2 fifths. So 3 times negative 2 fifths plus 4. And let's just simplify this to see what y equals. Y equals 3 times negative 2 fifths is negative 6 fifths. I can imagine 3 over 1. 3 times negative 2 is negative 6. 1 times 5 is 5. Plus 4. So, what is negative 6 fifths plus 4? Well, this is the same thing as 1 and 1 fifth, right? So I know that y equals 2 and 4 fifths. Now let's try it with the other equation. Y equals negative 2x plus 2. So y equals negative 2 times negative 2 fifths plus 2. Okay, so now y equals, again, I'm going to put the whole number over 1. Negative 2 times negative 2 is positive 4. 1 times 5 is 5 plus 2. What is 4 fifths plus 2? Oh, right. It should be exactly the same as the other answer. It's 2 and 4 fifths. So the y value is 2 and 4 fifths. So what does it mean that they have the same exact coordinate that gives them both the same y value when you plug in the same x value? That means when I use substitution, I figured out that this is the answer or the intersection because it's a solution to both equations.